Hello, my name is Joseph Peterson, and I will be teaching today about the applications of photon momentum. In this video, the questions we will answer include: how can a photon, which is massless, have momentum? Also, what evidence is there in the universe for photon momentum? Where have we seen this? Uh, how is it possible? And then what applications are there for this science? First, before we start getting into the equations and the nitty-gritty, I wanted to look at a short clip found in a movie that applies photon momentum technology. Granted, this is a fantasy or a science fiction film. It's called Treasure Planet, done by Disney. I'm sure most of us saw it as kids, and if you haven't seen it, I definitely suggest it. But as we watch this short clip, it's a solar surfing clip. I want you to keep an eye out for any of the science or science fiction technology, especially that focuses on light. You notice here he has a glowing sail. It seems to be absorbing or reflecting the light. He's got rockets, and sure he's having a blast. It also seems he has some pretty good grip on that board. I don't know if he's got magnets or something going on. It's another application of physics. Here's the sail again. Seeming to glow or reflect. I really loved this movie as a kid, but I never realized how much it had to do with a physics class that I would be taking in college. And there's the sail again. And just like that, we're back to physics. Hey. So, for sake of comparison, we're going to talk about this solar surfing scene, kind of like windsurfing. When you're windsurfing, you're out on a board on the water, and you have a giant sail that catches wind and pushes you forward. So as the pressure of the wind pushing against the one side of the sail, um, with that pressure, it will move you forward. Uh, you can almost compare the momentum of the air particles being captured by the sail um, to what happens with solar surfing. Uh, that momentum is captured by the sail and then transferred to the board or the ship or you, and moves you forward instead. Um, Now the question is, I compared this to momentum, right? Of the air particles, but how does that work for solar surfing? Um, Here we have an image of a giant solar sail up in the Earth's atmosphere, and it is supposed to be capturing sunlight, and then that will propel it forward. But the question is, how does that even work? Um, the thing that I mentioned earlier was momentum, and we understand that in our past physics classes as mass times velocity. So when something has a certain mass and is going a certain speed in a certain direction, those combined together equals your momentum. And that is why two objects going the same speed but having very different weights will have very different momentums, right? If you threw a feather at me versus throwing a bowling ball, one will hurt a lot more. Um, Whereas a bullet that is really, really small does not weigh that much, but is going very, very, very fast, also has a lot of momentum. So, as we were taught in Physics 105, momentum, at least according to Newtonian laws, is mass times velocity, and that's how we understand it. But we were talking about photon momentum. And how can photons have momentum? Uh, in the past, we've talked about them as a particle representing a quantum of light or other electromagnetic radiation, but also a wave. So it's a particle and a wave, but very importantly, it does not have mass. And as in the past, we've talked about that the frequency times the wavelength equals the speed of light, right? So obviously, these light waves travel at the speed of light because that is what they're being referenced to. And there's all sorts of waves, and they all are made up of photons. So gamma rays, X-rays, ultraviolet rays, any light in the visible spectrum, infrared light, microwaves, radio waves, are all carried by photons traveling through space. And they have properties of both particles and waves. That's really important to remember. So the question, can light have momentum? The answer is absolutely yes. In fact, it's been observed. One of the ways that it's been observed, of course, some of the early scientists predicted it using the math. But one observation is a comet that orbits the sun, uh, even as it is trailing. Normally, when you throw something, let's say a ball that has a string attached to it, the drag of the air will pull the tail in whatever direction that the ball is coming from, kind of like the tail of a comet, except when a comet goes around the sun, the tail always faces away from the sun, not necessarily in the direction that the comet is coming from. And this is evidence that light has momentum because the light rays coming from the sun are pushing dust off of the body of the comet away from the sun and not in the direction of the orbit. So that brings us to a new question. How can a photon have momentum if it has no mass, right? Our definition was mass times velocity is momentum. Well, here's the trick. At or near the speed of light, the Newtonian laws of physics stop applying in the same way. And what speed do photons travel at? The speed of light. So even though photons do not have mass, we have observed that they still have momentum. And so there was a new equation derived by scientists that is given by momentum equals Planck's constant over wavelength. And Planck's constant is 6.626 times 10 to the negative 34. And the wavelength, of course, is relative to whatever type of electromagnetic wave you have. So visible light would have a different wavelength and frequency than an X-ray or radio waves. So different types of light or different types of photons have different momentums. So the question is how do we actually use solar sails? Well, first they have to be very, very lightweight material and have a large surface area. But when this reflective material is spread out over a large space, and in this example, attached to a payload, maybe a satellite of some sort, or in the future, a spacecraft, we can possibly propel a spacecraft through outer space using the energy provided by the sun, much like in the age of sail when we sent explorers across the Atlantic Ocean on sailing ships like Columbus and Cortez. We might be able to send some solar sailing ships out into the galaxy and universe. It's really critical that this is low mass propulsion. And one of the solar sails that the United States is working on will be 40 meters squared, so quite large. There've been attempts in the past by the Soviet Union to send out a solar sail, and that ultimately failed. But when this works, if you can see in this diagram, the photon source, let's say the sun, will send rays parallel into the sail, which then reflects the light back. It's usually a shiny surface, and then that impact of the light wave transfers momentum from the light into the sail, which then can drive the payload forward. This is really, really incredible because it has implications for future space travel being much more sustainable, not using so much fuel, and it's just really cool. Now, going back to the video that we watched at the beginning, we won't probably anytime soon have solar surfing, especially not that acrobatic or heavy duty. His rocket powered board was much too heavy to be propelled by that size of a solar sail. Um, and he wouldn't be able to change direction quite so easily. But it is a very exciting idea and has some very fascinating implications. These are my references. Thank you for watching.